This is section 236. We're going to take a look at quadratic equations in real-life applications. And so in this lesson, we're going to apply quadratic equations to real-life applications. Now, before we go through the problems, there's one thing I just really want you guys to understand. With quadratic equations and the real-life problems, we're literally just doing a few things. Like if we have a quadratic equation and there it's modeling, we're either finding the zeros or the x-intercept. We're finding a max or min. Maybe sometimes the parabola goes that way, and so we have to find like a minimum. And so literally it's like various versions of finding the vertex or finding the zeros. It's literally just going to be different iterations of that. Now, sometimes we will have to create equation in the process, and so we just need to use the structure of previous equations to get whatever it is that we need to do. So, in this first one, it says the profit function is revenue minus cost. The weekly revenue in dollars made by selling X Portaboy game systems is going to be this R of X function, and we have the restrictions. The cost in dollars to produce X Portaboy game systems is given, and there's our cost, okay? So if it says determine the weekly profit function, it's literally just R of X minus C of X. And it's given to us in the problem. And so plug in R of X minus, plug in C of X, combine things together. Now, we just have to keep into consideration that it's only relevant from 0 to 166. Okay, so because the revenue was restricted, the profit is always also restricted to that. Now it's just asking us to graph it. And so for us to go ahead and graph it, we can create an XY table. It says include the XY intercepts. We know how to find the X and Y intercepts, right? The X intercept is we plug in 0 for Y and solve. The y-intercept, you plug in 0 for x and solve. So we've seen all those. There's nothing special about that. And then also we could use the quadratic formula, because this looks really complicated to factor. We can use the quadratic formula to find where it crosses. So remember, it's 0 equals your function. Okay, well, the quadratic formula is going to find where it crosses. And so if we have some sort of function, this is what we're going to be finding with the quadratic formula. And so I can use the quadratic formula. And yeah, it's in radical form. It's kind of weird, taking that information. Just use decimal. Like, we don't have to overthink it or anything like that. And so there are my x-intercepts. My y-intercept is -0, -150. And so again, just kind of modeling it. If I wanted to find my vertex, remember we said your x value is -b over 2a. Plug back in. And so if you plug that back in, you're going to get your y value. And so if I wanted to get a decimal approximation, we have that there. And then my zeros from the x-intercepts, we have these. I just entered the square roots into the calculator, and so it gave me these values here. And then you can kind of just sketch it from there. And then it also asked us to include the axis of symmetry, and so you can draw that in there. I know it has a lot of text just because I wanted you guys to be able to read kind of like what's going on here, but this is literally just stuff we've already done. We know how to find y-intercepts. We know how to find x-intercepts. We know how to find the solutions, quadratic formula. We know how to find the vertex, -b over 2a. It's really not all that fancy. So now we have to interpret it. And so that's where things get a little bit more. So we found that the zeros of my profit, okay, we found that was 0.89 and 112.44. Those are going to be your break-even points, right? That's where your profit is 0. And so the inequality of your profit being greater than 0, that's where you're going to make money. So in that graph, if anything between here all the way to here, because my profit is greater than 0, you make money there. Now, interpreting the vertex is going to be where you actually make the most profit. And so if that's my vertex, that's a maximum. And so if I sell 56.67 Porta Boys, I'm going to make $4,666. Now, because that does technically represent the profit, remember, I can't sell someone 0.67 Porta Boys. So you would have to either go to the left and sell 56 or go to the right and sell 57, examine which one's more. Well, if I plug those in, we ended up finding out that the P of 57 is going to be more. So that's going to end up being my max profit. So we still have to take the realism into the equation here. And so the max profit of $4,666.50 if we sell 57 game systems. Now going back to the price demand function. Okay, so if I give you this price demand function, negative 1.5x plus 250, where is the price, where P of X is the price per Porta Boy in dollars and X is the weekly sales, what should the price be? So if I found the maximum profit, it's saying I need to sell 57 of these. So then if I know I have to sell 57 of them, right, that's to maximize my profit. Well, to know how much I need to sell each one, we plug that into the price demand function, and we need to sell them at $164.50 to then be able to maximize that profit. So again, just to conclude everything, there wasn't really anything fancy that we did. We literally just used the information, we found the zeros, we found where it crosses, the x-intercepts. We can also find the y-intercepts, right? We can use the quadratic formula to find those zeros. You can use negative b over 2a to help you find the max or the min. And the rest just comes down to a little bit of interpretation. And we're going to go through this, we're going to practice it more, and we're going to get better at it. This does conclude our lesson. If you have any other questions, please leave them in the comments.